For this video, we're supposed to find the equation of the tangent line to y is equal to sine of x divided by 1 over cosine of x at x is equal to pi over 3. And we need to write the answer in slope-intercept form. First, the easy part of the question, let's figure out the point on the curve. So the point on the curve, we find this by plugging in pi over 3. And so that'll be equal to sine of pi over 3 all over 1 minus the cosine of pi over 3. The sine of pi over 3 is equal to square root of 3 over 2. And cosine of pi over 3 is 1/2. And so this simplifies to be square root of 3. Okay, so that's the first part of the problem. So let me just mark that as part 1, figuring out the point of the curve. So the point is going to be pi over 3 square root of 3. So that'll be my x1 and y1. All right, part 2 is going to be to find the derivative. Okay, and so to find the derivative, we have that y is equal to sine of x over 1 minus cosine of x. So let me copy that over before I scoot that out of off frame. And so to find the derivative, and I could write that as dy dx or y prime, it doesn't really matter. I use the quotient rule. So the derivative of the first, derivative of the top, times the bottom, minus the top, times the derivative of the bottom, all over the bottom squared. Okay, so derivative of the top is derivative of sine of x is cosine of x times 1 minus cosine of x minus sine of x times the derivative of negative cosine x. The derivative of cosine of x is negative sine x. So negative negative makes positive sine x all over 1 minus cosine of x squared. Okay, now formally I could plug in pi over 3 into this. However, I can simplify this considerably, and it's always a good idea to simplify when I can. Let me multiply out the first two terms. I get cosine of x minus cosine squared x. Multiplying these together, I get sine squared x all over 1 minus cosine of x, quantity squared. All right, cosine squared x plus sine squared x is 1, so I get cosine of x minus 1 over 1 minus cosine of x, quantity squared. Okay, now once again, I could plug in at this point. However, I can simplify this even further. If I factor a minus 1 on the top, I get negative 1 minus cosine of x over 1 minus cosine of x squared. And so this becomes negative 1 over 1 minus cosine of x. Alternatively, I could write this as 1 over cosine of x minus 1. Doesn't really matter if I multiply the minus into the denominator. Okay, so there is my derivative. So part 3 is to find the slope. And to find the slope, I would plug in pi over 3 into this. Y prime of pi over 3 is equal to negative 1 over 1 minus a half. And so that is equal to negative 1 over a half, which is negative 2. And so with that done, we now are able to find the tangent line. The tangent line will have the form, I'll do this two ways. So option 1, we can do y minus y1 is equal to m times x minus x1. And so I would have y minus the square root of 3 is equal to negative 2 times x minus my point for x1 is pi over 3. So the pi over 3 and the square root of 3 I found earlier in part 1 of this problem. And then if I multiply out the right-hand side and then bring the square root of 3 over to the right-hand side, I get negative 2x plus 2 pi over 3 plus square root of 3. And the y-intercept here is a little bit messy, but that's just as simple as it gets. Alternatively, I could write this as y is equal to mx plus b, and I know the slope is equal to -2. And then I plug in my point that I found. So if I plug in 2 pi over 3, I know that my point is square root of 3. That's supposed to be equal to b. Let's see, it says, sorry, plus b, pardon me. So square root of 3 is equal to -2 times pi over 3, the x, plus b. And then if I bring this term over to the left-hand side, I get that b is equal to 2 pi over 3 plus square root of 3. And so as before, I would get that the equation of the line is y is equal to -2x plus 2 pi over 3 plus the square root of 3. And so that would be the equation in slope-intercept form. For the exam purposes, either the black or the red would be fine for the last step. You certainly don't have to do it both ways. I did it both ways just in case someone is more familiar or more comfortable with one approach as opposed to the other.